Our next presenter is Chris Erickson. Chris is the President and Chief Executive Officer of Climate Earth. His company focuses on replacing the manual and labor-intensive approaches to life cycle assessment with scalable and automated systems. Today, Climate Earth's Carbon Clarity Suite and EPD generator is a leader in the industry and has generated over 30,000 concrete and concrete block EPDs. Prior to Climate Earth, Chris was a vice president of a Fortune 500 computer company and the CEO of 3 successful Silicon Valley startups. Chris holds a BA in economics and an MBA from the University of California Haas School of Business.
So I'm going to talk about the changing needs of manufacturers and buyers, what we see as a supplier happening broadly. And Anita touched on some of those things in her presentation. Before I do that, I also thought I ought to give you a little bit of where our perspective comes from for those of you who don't know us. We focus, as David said, on automation of EPDs, and in particular, more recently, we focused on a relatively simple product, ready-mix concrete and block. And it has, relatively few material inputs, like 100 or so typical, but really high variability of the products. They're designing new products and new mix designs all the time. And the operations are highly distributed, unlike Armstrong, which has a few centralized manufacturing plants. So it lends itself to automation. But what I'm going to be talking about is sort of what we've learned in working in the concrete industry, and also more broadly in construction, where we've done other types of EPDs, and what we've seen since we really dove into EPDs starting in 2012. So that's kind of where I'm coming from. And as I've mentioned, the EPD generation that we're doing now is spreading across the country, and the concrete manufacturers are really, really embracing this technology, or at least the leading ones are, to improve their carbon footprint and be more successful in the low embodied carbon marketplace. Anita talked about this as well. We've seen the EPDs evolve from what I used to call as being a tax on a lead job. We need an EPD, nobody looked at the data, they just hand them the document and you were good for a lead point. We see a continued interest in corporate transparency, but over the last few years, we're seeing EPDs shifting from being this sort of corporate report document to really just a verified report, almost like a meter, a performance meter of what's your embodied carbon footprint, or GWP, global warming potential, of your product, which has implications for manufacturers as well as buyers. And I'd like to sort of I'll dive into what we see those differences are and what the changes are. But I think now of an EPD as simply providing data around this new product performance metric called global warming potential. It's just a new design metric and a way to document it. So as I already mentioned, I'm going to break the presentation into 2 parts. First, talk about what we see manufacturers now wanting more and more. And secondly, how this shift to being a performance metric of the product changes the requirements and the thinking of buyers in the architectural, engineering, and construction community that we also work with on a regular basis. So what do we see? For manufacturers, and again, I'm saying we're informed a lot by concrete, which has a lot of change in their products, but we see the same thing happening in other categories as well. So the need is for ubiquity. I want a EPD for every product because I need to know about how we're performing, how each product is performing with respect to embodied carbon. We also see a lot of interest in having control. So traditionally, when we first started EPDs, the customer, the manufacturer calls us up, we're the consultant, we produce an EPD for them. But we're hearing our customers saying a lot that they really want to be able to control this metric. It's theirs. They want to be able to produce the data when they need it, and don't want to go out to consultants. And as volume increases, ubiquity, there's obviously a drive for lower cost per EPD, and then making the data from the EPD highly available to their buyers and customers. And what we found, and Anita walked through this this process, this sort of traditional EPD process is relatively slow. She mentioned that it can be a 3 to 6 month process. We see that speeding up. We also know that manufacturers of really more complex products like Armstrong can also now automate this manual process, document it, and move to a world of sort of partial automation where they only need to do a verification once a year, but their team of LCA experts can crank out EPDs throughout the year. But in general, this manual process does take 60 to 90 days. And if you're trying to innovate and change and you need EPDs not every 5 years, but maybe every year or sometimes even every 6 months, it's not as responsive to this new market-driven environment that we live in. And broadly speaking, EPD automation, where we focused on concrete, it meets their needs for the ubiquity, the control, much reduced cost, and the availability of the data. But it also, because of its general simplicity and the rapid turn they have, it's not completely relevant to every type of manufacturer, like an Armstrong or other manufacturers that manufacture more complex products. But the concepts that are embedded here and the requirements for more ubiquitous EPDs, rapid turn, using them to support innovation in a faster design cycle than 5 years, all are very relevant, I think, to all manufacturing processes. We think this is generally where the construction industry, the materials manufacturers need to move, is to greater ubiquity, control, reduced cost, and higher availability through different mechanisms, but all involving some level of automation. And I should say, once we go through this one single setup, just to give you a background on the approach that we take with concrete and actually concrete block, is we go through this process once, the 60 to 90 day process. After that, they're in a cloud-based system. They can generate unlimited EPDs each one in a matter of a few seconds. And then rather than going back through this entire process, we have a database of all their lifecycle inventory data and such. It's relatively straightforward to do at least an annual data refresh on their database to keep their EPDs fresh with new suppliers, new materials, new technologies, and that sort of thing. So the EPDs are always current. So turning to the buyer, they're really consumers of this data. So now, rather than thinking of an EPD as a sort of human-friendly 16 or 18-page PDF, we want to be digitizing this data. And one of the beauties of EPD automation is the data is digitally native. And what that means is it's more consumable. Because the buyers, the architectural engineering community, what we're hearing very loudly from big construction companies through to architects and engineers, is they're starting to use the EPD data for making purchase decisions. So they need to do that through digital analysis, the cost and time to manually review dozens or hundreds of EPDs for a single large construction project just it just can't be done. It's not cost effective at all. But the EPD is also becoming a building block for whole building life cycle analysis. So as architects are designing buildings, they want to look at the whole picture and make a decision about, concrete core, wood core, steel core, and what are the implications, the long-term implications for embodied carbon. The ideal building block for that whole building LCA is the EPDs coming directly from manufacturers. Same thing for building information modeling integration, to look at visually where are the hotspots in a building, where should I address my attention, the embodied carbon hotspots. And then a little bit less so, but still really important, is what I call purchase cycle tracking. That is, and this is especially true for concrete, is the concrete mix I designed actually go through the entire construction cycle and end up as the actual material that was put into the project. Sometimes that changes for good reasons, like weather conditions, as the project progresses and something, but being able to track that and actually know how your design compared to the as-built is becoming data that's of increasing interest. So this shift, essentially in sum, this shift from being a lead report to the foundational meter for measuring global warming potential is causing shifts throughout the industry, both on the buyer and manufacturer side. And what we see is that this digitization is really key to meeting the buyer needs, in that, when we enter a digital EPD, it's generated. This is illustrating the workflow, but this is what's needed really for all products, some kind of transition from the core output of an EPD being a PDF, which is not at all computer friendly, to being in a digital native form. And there's lots of work around the world happening with that. We were a pioneer with Phil in developing the initial version of the digital EPD, but that means we can instantly post an EPD that's generated back to the client. We can post it at the program operator site. And then also we can go ahead and post those EPDs with EC3 or with other design tools and decision support tools. EC3 is happily collecting about 31,000 of our EPDs at this point. And we only expect that to scale up. I mean, 31,000 sounds like a big number, but with respect to the digital infrastructure we currently live in the Google world, as I like to call it, it's actually quite a small number. And this is just one material type where we need dozens and hundreds of material types, from wallboard to steel, to which they're collecting in EC3 so that this whole analysis can be done. So in essence, the digital EPD is the meat